Hello everyone, welcome back to another episode of our farming RPG tutorial series. In this part, we will address several bugs reported by our community and implement a new Minecraft-style inventory system. Last episode, we fixed the bug that overrides the hand slot when the player picks up an item while holding another item. Since then, some of you guys reported on our forums that when harvesting tomatoes, items already in their hands were getting overwritten. The issue lies in our regrowable harvest behavior script. We simply need to add the same checks in the pickup method as we did for the interactable object the last episode. And for better UI feedback, we disabled the interact prompt after picking up the harvestable crop. Next, we'll tackle a more complex bug. It was reported on the forums that when hatching multiple eggs simultaneously, only one chick would remain after saving and reloading the game. This is a classic race condition in our animal stats script. When multiple eggs hatched at the same time, the code was accessing and modifying shared data on the blackboard at the same time. We are retrieving the animal count and type count before the player even named their animal. And we realized that the solution ended up being more straightforward than my initial answer in the forums. By simply moving our blackboard operations inside of the naming prompt callback, we ensure that these operations happen only after the player has named their animal. This naturally prevents the race condition entirely. Each animal creation now completes fully before the next one begins, ensuring that all animals are properly saved. Now, by popular demand, let's touch up on the inventory system. This will allow the players to manage their inventory more intuitively. So what better system than have it work like Minecraft? To start, let's change up the inventory slot script to have slot index be protected, so that we can access it over in the hand inventory slot. Let's make some changes over in the onPointed click method to check for right clicks and shift key presses. Now when we left click with shift, it calls the move entire stack function, which we did in our previous setup, which is to just move the entire thing to either the hand or to the inventory. The others call the select slot method, which we'll add to our inventory manager. This gives players multiple ways to interact with the inventory items. For hand inventory slot, we added an awake method, setting the slot index to -1. This is our special identifier for the hand slot. We also refactored its click handling by moving the functionality to a new move entire stack method. We also need to make several changes to the supporting scripts. In item slot data, we've updated the add quantity method to call validate quantity after modifying the quantity. This is because we want to pass through negative values in this function too. We then add new variables to the inventory manager to track the currently selected item and its original position. And with that, we can implement the select slot method, which handles all possible interaction cases. Having it work like Minecraft, we need our inventory system to manage scenarios based on whether the player has anything selected and whether the slot that he selected has anything in it. And these are, when the player has nothing selected and he clicks on an empty slot, nothing happens. When the player has nothing selected and clicks on a slot with an item, if he left clicks it, he picks up the entire stack, while right clicking picks up half of it. When the player has an item selected and clicks on an empty slot, left clicking places the entire stack in. Right clicking places just one item. When the player has an item selected and clicks on a slot containing the item, when he left clicks and the items match, they stack together. If he right clicks and the items match, he just adds one to the stack. If they are different items, they swap places. To support these interactions, we've created helper methods that handle moving items between slots, retrieving slot data, and swapping items. First, the slot to selection method handles moving items from a specific inventory slot to the cursor selection. It takes 3 parameters: the slot index, inventory type, and an optional quantity parameter. When we set the quantity to -1, it transfers the entire stack. Otherwise, it transfers only the specified amount. This is very important for right-click operations when we need to split stacks. Next, selection to slot does the reverse. It moves the currently selected item to a specified inventory slot. The method first determines which inventory section to modify based on the inventory type. If the slot index is -1, it places the item in the equipped slot. Otherwise, it places in the appropriate inventory array. Then it clears the selection and resets the original index tracking variable. The getSlotData method provides a unified way to access slot data regardless of where it's located. It handles both regular inventory slots and the special hand slot, which is indicated by the index -1. And finally, we made a function to swap selection. The swap selection method exchanges the selected item with the contents of a specified slot. First, we just simply have to cache the selected item and then retrieve the target slot's data and makes it a new selection. Then it places the cached item into the target slot. And now, with our selection logic in place, we need a visual representation to show what item the player is currently holding. In the UI hierarchy, under the inventory panel, we created an image and a text mesh pro component to be our cursor. This is a copy of our hand slot, and we just remove the image component of the slot parent. So it just has the image of the item and a text mesh pro component inside of it. Next, we made a script to control it, selected item display. The script manages an image component that displays the selected item's thumbnail, and a text component that shows its quantity if greater than 1. The start method initially disables the display, while the render method updates it based on the current selection. The update method continuously adjusts the position to follow the mouse cursor. This gives players clear visual feedback about what they're currently holding and where they'll place it. I realized that the cursor blocks the player from selecting the slots, so I added a small offset to it as well. We've also updated the UI manager to render the display whenever the inventory updates. This creates a seamless connection between our selection logic and the visual representation that players see on screen. Finally, we need to ensure that players don't accidentally lose items when closing their inventory. To accomplish this, we've added a cancel selection method to the inventory manager. This method first checks if the player has anything selected. If they do, it determines whether it's a tool or regular item, and then returns it to its original slot. We call this method whenever the inventory panel closes by adding an onDisable method to our selected item display script. This safety mechanism prevents items from being lost if a player closes their inventory while holding something. Instead, items automatically return to their original positions, maintaining inventory integrity at all times. And that's it for today's tutorial. If you run into any problems while following our tutorial, you can simply make a post on our forums, post your code like all the others have. Who knows, maybe you'll spot a bug that we can fix in the next part. If you would like to download the project files for this series, they're available for our silver tier patrons. Thank you as always for your support, and we will see you next time.